So when we are trying to balance symbol equations, we've got to assume that there's going to be a number in front of each of the compounds, okay? So that's the first thing that we do. We put letters in front of each of the compounds. So there's going to be a number in front of PCl5, so that number we can say is going to be A. There's going to be a number in front of H2O, so we're going to say that number is B. There's going to be a number in front of H3PO4, so we call that C, and we call the one in front of HCl D. Now, if that number is 1, then we will not write that number because we don't write the number 1, but you could if you wanted to. It wouldn't be wrong. None of those numbers are going to be 0. There's going to be something in front of each of them. Okay? So the next step is for us to set up a number of equations that allow us to solve for each of those letters. Now, in maths, you'd have done this before. They're called simultaneous equations. The fact there's 4 unknowns means that we need to have more than one equation in order to solve it. So to set up those equations, what we will do is write an equation for each of P, for Cl, for H, and O. I'm going to start with P. So remember that our law of conservation of mass says that whatever is on this side of the equation, that has to end up on this side of the equation as well. There needs to be the same number of each type of atom on both sides of the equation. So, in terms of P, if I was to work out how many P's there were on this side of the equation, there's only one P, phosphorus, in this compound. There's none in this one. So only this number here, A, is going to affect how many phosphoruses there are on that left-hand side. So, the number of phosphoruses on the left-hand side is going to be A. There's going to be 1A because there's only one phosphorus in this. So whatever number A is, that's the same as the number of phosphoruses as well. Because there's only one phosphorus in that compound. So that's how many there are on the left-hand side. That has to equal the same number on the right-hand side. So let's look on the right-hand side and see how many phosphoruses there are. There's 1 in this compound, and there's none in this compound. Okay? So again, whatever C is, that's going to be the same as the number of phosphoruses on the right-hand side. So A is going to equal C. Okay? It has to, because that's the law of conservation of mass. However many phosphoruses on the left-hand side has to be the same as the right-hand side. So A must equal C in order for this to work. If I now look at the hydrogens, okay, so for the hydrogens, there are 2 in this formula, and there's nothing in this one. So to calculate how many hydrogens there are on the left-hand side, it's just going to be however many, whatever this number is, B, whatever B is, multiplied by 2, because there are 2 hydrogens in water. So that's going to be 2B on the left-hand side. That's going to have to equal however many hydrogens are on the right-hand side. So on the right-hand side, we've got 3 hydrogens in this compound and 1 in this compound. So whatever C is, we have to multiply that by 3 to get how many hydrogens there are there. So it's going to be 3C, but there's also a hydrogen here. So we have to also add whatever D is in order to get how many hydrogens there are on the right-hand side. Again, the number on the left-hand side has to equal the number on the right-hand side. So that's why they equal each other. This is the left-hand side of the equation. This is the right-hand side of the equation. Let's carry on. We now need to do Cl. So Cl is going to be only in this compound on this side. There's 5 Cl per compound. Per molecule, sorry. And so whatever A is, that'll be multiplied by 5. That'll tell us how many Cl's there are. So it's going to be 5A. That equals, because it has to equal whatever's on the right-hand side, Cl is only in hydrogen chloride here, or hydrochloric acid. And so whatever D is, that's how many chlorines there are. So that equals D. 5A equals D for the Cl's. And then finally, for oxygens, you're going to try fuse yourself in a second. We've got 1 oxygen here, nothing in this one. So whatever B is, that's going to be the same as how many oxygens there are. So that's going to be B equals, and on the other side, we've got 4 oxygens per molecule here. So it's going to be 4C. Whatever C is, I'll multiply it by 4. That tells me how many oxygens are on that side. So B equals 4C. So now I've got my equations. These are my, in maths, these are kind of your simultaneous equations we've got to solve for. But the way we solve them is different to maths because we can say, we're allowed to state what one of these numbers is. Okay, and the easiest thing for us to do is just to say, well, let's just say A is going to equal 1. Okay? And then all the other numbers will lead from that because they just have to be the right ratio. It doesn't really matter what the numbers are as long as they are the right ratio. So if A equals 1, let's start with this top one. C equals A, which equals 1. So therefore, C equals 1. Okay, so use the equation. That means this number must be 1. If I want to work out D, D equals 5A, which equals 5 times 1, because I'm getting it from here, and that equals 5. So D must equal 5. Finally, I can work out B in 2 ways. Either I can substitute in my C and D, which I've just worked out, into this equation, and then rearrange to find B. But actually, this last one's probably easier, because it's just B equals 4C. So B equals 4C, so B equals 4 times 1, because we just worked out C equals 1, which equals 4, so B must equal 4. Now what we can do, just to check if we've got enough equations, sometimes you won't have enough equations, because there'll be less than 4 atoms in the whole equation. We can just use this equation here in order to check our answer. So 2B should equal 3C plus D. So 2 times B, which is 4, should equal 3 times C, which is 1, plus D, which is 5, which equals 8, and 4 times 2 is also 8. So now I know it is balanced. Okay? So the 3 steps are first to work out your different equations, okay, by labeling your numbers A, B, C, and D, or more if there's more on you have to use E or F if there's more compounds in the equation. Then set up your equations, make one of your numbers a certain number. I could have started with 2 there or 3, okay, it would just given me different numbers here, here, and here. Okay, so but if you set it as 1, then the rest will follow, and then solve your different equations. It won't necessarily be in that order. You'll have to solve the one you can solve first, and then use those numbers to solve the other ones.